In this video, we are going to look at how to get a Maclaurin series from a known series. Okay, so we know already, and we derived that the series for sine x looks like this. We start at 0 to infinity, then we go to negative 1 to the power n, that alternates signs of the series. Then we're going to have x to the power 2n plus 1, so it's only odd terms, and then divide that by 2n plus 1 factorial. Now, the radius of convergence here is infinity, which means that the series will converge for all x, and using the remainder theorem, you can also prove that it'll actually converge to sine x. Okay, but let's say we want to know what is the series for sine of x cubed. So what we do is we just plug in, instead of x, we are plugging in x to the power 3. Okay, everything else is going to be the same. So instead of x in the formula, we are plugging in x cubed, but also we're going to need to use properties of exponents here. So let me do that. So we got x cubed, and that's further raised to the power 2n plus 1. And then we're dividing that by 2n plus 1 factorial. Now, we need to understand that there is a formula for rules of exponents when you're raising something to a power and then further to another power. What will happen is the powers are going to multiply. So what that means is the 3 will be multiplied by 2n plus 1. And I would always recommend putting it like in parentheses or maybe just in your head to understand that that 3 will actually be distributed to all terms. So we are going to wind up with negative 1 to the power n. Then it's going to be x, if 3 multiplied by 2n is 6n, plus 3. And then we're dividing that by 2n plus 1 factorial. Okay. And by the way, radius here, we can already put that that's infinity, because that series always converges. Whenever you see that factorial on the bottom, that's usually what that means, is that it's just going to outrun everything else. It's going to drag it to 0. Okay, that's not the final answer, though, because we also have to multiply everything by x to the power 7. Notice that we can only do these kinds of things with powers of x. So if it wasn't power of x, you couldn't just substitute it for x, okay? You have to have a power, because this is power series. Okay, so we are multiplying everything by x to the power 7. Now we need to use more rules of exponents. This time, so this was one of the rules that you need to know. The other one looks like this. If you have something to a power multiplied by something to another power, this is actually the powers will add. So what am I talking about here? I'm having 7, and then I also have 6n plus 3. And this time I'm adding the powers, right? So that will give me the final answer. So I'll get negative 1 to the power n. X is going to be 6n plus 3 plus 7, which is 6n plus 10. And then I'm dividing that by 2n plus 1 factorial. Okay, so let me just see if I can type that and hopefully get that right before. Oh, yeah, you have to put this in parentheses, otherwise it's not gonna understand it. All right, let's see if that's right.